All right, here we go. The final piece of the entire class. Congratulations to all who made it here. This is the last thing you need to learn to get through the class, and I think it may be by far the simplest that we've had in a long time. So, this is Kramer's V, and just like we used Pearson's R to understand the strength of the relationships between categories or subjects, right? Just as we use that for the variables, we use the Pearson's R to understand the strength of the relationship. Kramer's V is to help us understand the strength of the relationship with variables using from chi-square, right? So phenomenal data. It's just like, so here we are, we have PowerPoint. So let me open it up. Just like Pearson's R, right? Here's your checkpoint. What? Well, no, that's not helping. A second. Hold on. Try this again. There we go. Sorry about that. So here we are, Kramer's V. So like I said, this helps us to understand the strength of the relationship between variables once we see there is a relationship, right? A correlation. So for the t-test, we use Pearson's R, and now with nominal data, we use chi-square, and we use Kramer's V to establish the strength of that relationship, right? Very simply, here is the formula for Kramer's V, right? V is equal to the square root of x squared, or a value of chi-square, over n, which is the total number of, and I will fix this, obviously, what I had. It's the total number of subjects, our grand total, right, like we talked about earlier, and k minus 1. K is the lesser value between rows and columns, right? And so in our example, we had two rows and 3 columns, right? And unfortunately, I probably should have carried that through here, but I didn't. And I said for this example, we had 3 rows and 4 columns. And anyway, right, so K is the lesser value between the rows and the columns. So we have 3 rows, 4 columns. Obviously, K is equal to 3, the lesser of, right? So if we look at our table, and I went back, oh, so I did. I guess I should update that. Anyway, here we go, right? So here's our table, here's our stuff. We know x squared is 55.52. We know n, the grand total, is 479. And we have 2 rows and 3 columns. So k is equal to 2. So right here, that's all we did. We plugged in the numbers. V is equal to the x squared, 55.52, over 479 times 2 minus 1, or 1, right, which is basically 479. So the square root of 0.1159. When you divide this by this, you get 0.1199. See, I gotta clean that up. None of these changes stuck. Anyway, I will clean that up for when you look at it in the modules and get rid of that little x. Anyway, so we got this. The division is right anyway, and so here is the square root, and so that is 0.34, right? As I said, 1 is the maximum value, and in this case, 1, the perfect relationship, would actually be demonstrating causation, which, as we know, is like extremely difficult to prove. So 3.3 is actually like a moderate relationship, right? So we really look between 0 and 0.5, and you don't need to know any of this for the exam. But I will let you know that 0.30 is, or in our case, 0.34 is a moderate, what we consider a moderate relationship. It's not extremely strong, but it is strong enough to have an impact. Like I said, that was the simplest, I think, of anything we've done in a while. Hopefully, it was a good, simple enough presentation, and that'll be it. So, congratulations, you made it to the end. I hope you got something out of the class, even if it was just passing to move on. And if you got a better understanding of statistics, I am grateful. This is it. You're going to do your Unit 5 work, and good luck in your future.